For this last example, we're going to do some investigation into the waiting times between buses at Dan's bus stop. Previously, the average waiting time between buses was 18.3 minutes. But the bus began a new route, and during a random sample of 5 instances using the new route, the waiting time between buses was only 15.1 minutes. And we calculated the standard deviation of that sample to be 6.2 minutes. So what we want to test is whether or not that's enough information to conclude that the mean waiting time between buses is now actually different from what it used to be, which was 18.3 minutes. So our null hypothesis is going to be the claim that the mean waiting time is still 18.3 minutes. And if our evidence suggests that we should reject that claim, I'm going to adopt the claim that the mean waiting time is actually now different than 18.3 minutes. So this is going to be a two-tailed test with a 5% level of significance. If I reject the null hypothesis, there will be less than a 5% chance I'm wrong in doing so. To do this hypothesis test, we're again going to have to use the student's t-distribution. And the reasoning is that sigma is unknown. I don't know the standard deviation of the population. So I'm going to use the sample standard deviation in my calculation, which is going to give me a t-value. Plugging in my numbers, including a sample mean of 15.1 minutes, I get a t-value of negative 1.15. Again, with any t-value, I need a degrees of freedom with it. And in this case, it's 4 because the sample size is 5 and the degrees of freedom is n-1. So to compute the p-value for this test, I actually need to find the area down both ends of the distribution, being at least 1.15 standard deviations away from the mean, either way. In order to do that, I need to use my student's t-table. Now on my student's t-table, I go directly to the degrees of freedom that I'm using, which is 4. And again, I'm going to go across this row and I'm going to look for the t-value that I calculated. Now, this table only lists positive t-values, but since the curve is symmetrical, it doesn't matter if I'm looking up a negative or a positive t-value. I can just look up the positive number. But what we might notice is right off the bat, the very first t-value is already bigger than the t-value we calculated. In other words, when I have degrees of freedom equal to 4, if I had a t-value of 1.344, the two-tail area for that would actually be 0.25. So again, as the t-value gets bigger, the tail areas get smaller. So since our t-value is actually to the left of this, it's smaller than 1.344, the area, the two-tail area, is actually bigger than 0.25. Going back to my example here, off of another t-table, I would have known that the p-value was bigger than 0.25, but it actually is less than 0.5. However, this is still a very, very large p-value. This is actually the first time in our 4 examples that the p-value is greater than alpha. So my conclusion for this test is that I am not going to reject the null hypothesis. If I were to reject the null hypothesis based on this data, there would be between a 25 and 50% chance I would be wrong. That is way too high for me to make that claim. So my conclusion is that I have failed to reject the null hypothesis. Now it's key here to note that I did not prove the null hypothesis is true. I only failed to reject it. And the reason why I failed to reject it is based on a few factors. You might think at first glance that the new waiting time was 3.2 minutes shorter, and that might seem like a lot. It's over 15% difference. But one of the problems with my test is that the standard deviation was very high. It was 6.2. And in addition to that, my sample size was very low. It was only 5. I would have had to have had a much more extreme difference in waiting times for me to reject this null hypothesis just based on a sample of size 5. Either that or I would have needed a sample standard deviation much smaller. It's apparent by the standard deviation that although my mean waiting time was only 15 minutes, there was probably a lot of variance involved in that calculation. So the combination of the high standard deviation along with the low sample size actually ended up creating a very small t-value for my test. A small t-value means I'm close to the middle of my distribution, which means the tail ends are quite large. So that, in part, is why I ended up failing to reject the null hypothesis in this case.